So set A, just all the single digits. B, 3, 5, 7, and C is 0, 1. And these are both clearly subsets of A. So as far as I can tell right now, A would be the universal set. But whether or not we'll need that, we don't know. So how many subsets of A do not contain any of the elements of B? Okay, so if I'm looking at subsets of A that don't contain elements of B, I'll just write out A here for a moment. Let's remove what's possible. Right? If I'm picking things from from A and I want it to be a subset, but I don't want to have anything in common with B, I can't use 3, I can't use 5, I can't use 7. Automatically, I have no choice. Cannot use those. Okay, but for every other element, I've got two choices. Am I going to include 0 in my subset or not? 1 in my subset or not? Two choices, two choices, two choices, over and over and over and over again. Okay, 2 times 2 times 2. Is it in or is it out? Is it in or is it out? How many do I have here? Well, I've got 7. So the number of subsets of A that have nothing in common with B, 2 to the power 7, or 128. Okay. How many subsets of A do contain subset B? Almost the exact same thing, except instead of saying you can't have 3, you can't have 5, you can't have 7, we're now saying you must have 3, you must have 5, you must have 7, but there's still no choice. Everything else, 0, 1, 2, these are all choices. Are they going to be in the new set I make or not? But 3, 5, and 7, if B is going to be a subset of the set I make, you have to have 3, you have to have 5, you have to have 7. So there's no choices involved there, and the answer is still 2 to the power 7. Okay. How many subsets of A contain subset B, but not subset C? Okay. So again, let's think about it. What choices do I have? Okay. We're sort of moving beyond sets. We're thinking about breaking problems down in terms of choices, sequence of choices, and a set of different cases. Okay, so for C, we say we need to contain B, but we can't contain subset C. So right away, I know, aha, 3, 5, and 7 have to be in. No choice, they have to be in. Now, I'm a little worried about 0 and 1, because if they are both in, then C would be a subset of the set that I'm going to make. Okay? But 2, well, I could choose. I'm going to make a brand new set. I've got to have 3, 5, and 7. Could 2 be in there? Well, it could, or maybe it doesn't. Okay? 4, I've got two choices. Is 4 going to be in my new subset or not? 6, is it going to be in my new subset or not? 8, is it going to be in my new subset or not? 9, is it going to be in my new subset or not? Okay. But then the question becomes 0 and 1. What do I do with them? If I say, is 0 in or not? Is 1 in or not? Well, it's possible that they would both be in. And if I create a brand new set and it's got 0 and 1 and some other stuff, then C is a subset, and we are specifically trying to avoid, we don't want C as a subset. You can have some of the elements of C, but not all of them. Okay? So we don't want to say 0, are you in or out? We have to consider 0 and 1 together. Okay? So we've got a few possibilities. Have 0, but not include 1. Okay? Have 1, but we don't have 0 in my new set. Or don't have 0 or 1. So there's 3 different cases when it comes to 0 and 1. So 3 choices for what do I do with 0 and 1 together. 3 times 2 times 2 times 2 times 2 times 2. Which I could simplify as 3 times 2 to the power 5. So there's C there. And while we're at it, let's do D. Contain at least one. How many subsets of A contain at least one of the elements of subset C? Okay, so this is similar to sort of question we have already talked about, but how many possible subsets are there of A? Right? A has 10 things in it. So it's 2 to the power 10 subsets of A. Okay. Now we want at least one of the elements of subset C. So we could have 0, we could have 1, we could have both of them. Okay. So among these subsets, some of them are subsets without 0 or 1. And we don't want that. We want to remove that from the total. So how many subsets are there of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 that don't have 0 and 1? Right? So think about it. Well, I don't have a choice. I can't have 0 and 1 because that's part of the condition that makes these. So no choices there. 2 choices, 2 choices, 2 choices. There's 8 of these. 2 to the power 8 subsets that don't specifically have a 0 or a 1. So 2 to the 10 minus 2 to the 8. Not so bad. And we've got one more, and that'll finish off 9 here. How many subsets of A have more than 2 elements? So again, I mentioned this earlier, the less than, at least, at most. This is a more than situation. Okay. So if I'm thinking subsets that have more than 2 elements, okay, they could have 3 elements, or 4 elements, or 5 elements, or 6 elements, or all the way up to 10 elements. And that's kind of going to be difficult to work with. On the other hand, we might say, well, there's 2 to the 10 subsets. And again, use this technique of get rid of what we don't want. Okay, subsets with no elements. How many ways are there to pick a subset out of all those possible subsets that have no elements? Well, there's only one subset with no element, our beloved empty set. Okay. How about subsets with exactly 1 element? Well, if I'm going to create a new subset with exactly 1 element, I have 10 things to choose from. I have to pick only one of them. So maybe I pick 5, or maybe I pick 9, and that becomes my new subset. Right? So how many choices are there for which of these 1 elements to pick? 10. And then here comes the tricky one. How many possible subsets are there to pick with exactly 2 elements? Right? How many ways are there to do that? Because we also have to remove that. Because we want more than 2 elements. So we can't have 0, we can't have 1, and we can't have exactly 2. We need to have 3 or 4 or 5 or something. Right? So what do we do there? Okay, and this is where, if you are up to date with 1.5, the answer is quite quickly 10 choose 2. Okay? And I'm going to leave it like that because that's the way you would be able to answer on sort of a multiple choice test question, because we would know 1.5. But if you're a little sort of nervous, you say it's a 1.3 question. You're not allowed to use future notation. I agree. Okay? So instead, let's briefly talk about how I would pick exactly 2 2 elements from here to make a subset. Okay. So I've got 10 choices for my first thing. I need to pick 2 of them, so let's pick one of them. So the first element I pick. Okay. Once I pick 2, and 2 becomes part of my subset of size 2, I've got to pick another one. Can I pick 2 again? Well, no, I already chose 2. So 9 choices are left over for the next element. And so then maybe I pick 7, and 7 joins my set. Now I've created a subset with only 2 elements. 10 choices, and then I had 9 choices. You'd say, 10 times 9. Right? That's the number of ways to make subset of size 2. But go back and think. Right? What if, for my first element, when everything was fair game, I had chosen 7? And then I've got 9 choices left over, and I picked 2. I've created a set, 7, 2. How is this different from 2, 7? Well, It's not. Sets don't care about order. Sets just care what's in them. So I've done what I mentioned earlier. I've done something called overcounting. I have counted the subset, the same subset, 2 different ways. So to correct for that, we divide by 2. And if you're saying, well, I don't like where this is going, this is why we introduced this concept in 1.5. But if you absolutely must have an answer from 1.3, here you go. You would subtract 45 different ways to pick subsets of size 2. But that's not really a question we typically expect at that point in the course.